In this lecture, we're going to look at abstract classes and methods, as well as a couple of other odds and ends regarding inheritance. So in regards to abstract classes and methods, when you declare a class as an abstract class, what it means is that then you cannot instantiate an object of an abstract class. Now, when you write an abstract class, it may or may not contain abstract methods. If you do have an abstract method, what that is an undefined method which then must be defined in the subclass. If that abstract method is not defined in the subclass, then that subclass must also be abstract. Now what I mean by defined is it must be implemented. That means it's going to have a method body. When a subclass actually implements an abstract method, it has to use the same method signature. Now one of the reasons that we declare abstract classes and methods is it's a good place to factor out common behavior that's going to be needed by the children of this particular abstract parent. So I think an example will help clarify. So I have an example here. We've got public abstract class shape. And for example sakes, this is just going to have an area that's associated with the shape. And then we've got two abstract methods and then one concrete or actually implemented method. What I mean by concrete is the method is actually implemented the full method body and there's actual code in there. The way an abstract class works is all we do is we just add the word abstract. Once we have done that, that means that we cannot instantiate an object of type shape. Now there's probably reasons for this because it really makes no sense to have an object of type shape out there is because when we make a shape, it's going to be a very specific type of shape. Now once we've declared that, we have the option then of having abstract methods. In this particular instance, we have two abstract methods. One of these is draw. The reason that we don't implement the draw method here is that we do not know what type of shape we are, so it's going to be different if I'm a circle as opposed to a triangle. I'm going to be drawn differently. So when I declare it as abstract, notice here I just put the method signature, public abstract void draw. There is no method body, so I don't have an opening and ending curly brace to signify method body. I just put the semicolon there. And the same thing here for this abstract method compute area. It's going to be different to compute the area based on whether I'm a circle, triangle, square, or rectangle. But when I declare them as abstract, that means when a class extends the shape class, for example here, circle extends shape, what that does is it inherits all the data members and methods of the shape class. So it inherits the area, even though it doesn't have direct access to it because it's declared as private. It inherits the getArea method, and this is a concrete method. It's already been implemented, so I do not need to re-implement the getArea method down in this particular one unless I want to override the functionality. Since I've already inherited those, I don't have to do anything more with the area or the getArea. However, because I have an abstract method draw and an abstract method compute area, I then must actually implement these down in the circle class. So I've got public void draw, I've had my method body, and then here's where I would actually put my code in. And then public double compute area, I would have to then put in the actual lines of code in the method body here. So what this does, when the circle extends shape, because they're declared as abstract, it forces me to implement them down here. Now if I did not implement those and I got rid of the method body here and just put a semicolon, then it would force me to actually declare the circle class as an abstract class. But more often than not, we'll just have a parent that's an abstract, and then the children will actually have a concrete implementation of those methods. Here's another example, public class triangle extends shape. Again, it inherits the area data member and the getArea method, and then it has to implement the draw and the compute area methods because they are abstract methods. So this is a good way to capture generic properties and behavior within the abstract class and then help guide what we must implement in the children classes. And then you'll get more practice with this in the actual homework. I also want to touch on overloading a method versus overriding a method. Remember that overloading is we have multiple implementations of the same method within a class or within a class hierarchy. We've seen an example of this where we've had multiple constructors within a class. Remember, overloading is it's the same method name, but the signature, which means it's going to have a different type and or number of parameters. Now, overriding has to occur between classes, and this is where you have the same method signature within a class hierarchy. It's just in a child class, we're going to override, we're going to change the behavior of a method that's already been implemented in a parent class. So last time we looked at two ways to do this. One was full overriding, is where we don't leverage any of the behavior that was implemented in the parent, and then partial overriding, where we're going to use the call to super and then that method that's being overridden, and then do some additional functionality with that. So overloading and overriding are two different things when it comes to inheritance. Now I'm going to look at the attribute final, which can be used as a attribute on a class or a method. If you declare a method as final, that means that it cannot be overridden in a subclass. So it's a way to force the implementation to be used by all subclasses. And then if a class is declared as final, then that means it can't be subclass, it can't have any children. The last thing I want to look at is when to use inheritance. Last time we looked at this is-a. So if we have an is-a relationship when we're sort of defining and designing our system with various objects that we may think we have a system, then we're going to start thinking inheritance, where the child is a more specific version of the parent. Or if we had a has-a relationship between objects in our system, then we're going to think more of a composition, or it's going to be now a data member of a class. So here, the example, we've got the car has a tire, so that means has a composition. We're going to think that then a tire is going to be a data member of the car class, or if I say car is a vehicle. Now we've got the inheritance because we have the is-a relationship, so we have that car is going to be a subclass of a vehicle. So that's all I'm going to cover in this lecture. The homework should help solidify some more of these concepts.